Hello everyone, and welcome to Earth Archives. Today, we're going to take you into the world of a true superhero in the field of astronomy, Johannes Kepler. While his name may not be as universally known as Einstein's, his contributions to science are absolutely undeniable. Kepler was not only a brilliant astrophysicist, but also an astrologer, and his research in astronomy laid the solid foundation for the later scientific revolution. In particular, his 3 laws of planetary motion completely transformed our understanding of how the universe works. Imagine these laws as the invisible hand of the universe, subtly guiding the orbits of the planets. Today, as we reflect on Kepler's story, we are not only celebrating his astronomical achievements, but also honoring his unwavering dedication and innovative scientific spirit. If you are fascinated by the cosmos and the motion of planets, then Kepler's 3 laws are definitely scientific treasures worth deeply understanding. Kepler's early life, an imperfect beginning. Johannes Kepler, the great astronomer, was born on December 27, 1571, in Würzburg, Germany. However, his life was far from perfect and was filled with challenges and hardships. His family was not wealthy, and his father left home early, leaving his mother to raise him on her own. The pressure of life meant that Kepler's childhood was not as carefree as that of other children his age. Furthermore, Kepler was born frail and sickly, and in his early years he suffered from deadly diseases like smallpox and measles. These illnesses nearly claimed his life and left him with lasting vision and mobility impairments. Despite all these difficulties, nothing could extinguish his love for science. Instead, these struggles planted the seeds of perseverance and a thirst for knowledge in his life. At the young age of 6, Kepler witnessed the appearance of Halley's Comet. The comet, with its tail stretching across millions of kilometers, was like a brilliant spectacle in the sky that captivated young Kepler. This astronomical event became a turning point in his life, sparking a growing interest in astronomy. Although the field of astronomy at that time was still stuck in many ancient theories and had not yet entered the modern scientific era, none of this could stop Kepler's pursuit of the mysteries of the universe. At an early age, he began to teach himself the fundamentals of mathematics and astronomy, striving to uncover the laws of celestial motion. This thirst for knowledge and unwavering dedication would ultimately be the foundation that enabled him to overcome numerous obstacles and become one of the giants of astronomy. Despite this, Kepler's educational journey was not without obstacles. Due to his family's financial struggles, he was unable to enjoy the same educational resources as children from wealthier families. However, this did not diminish his thirst for knowledge. Kepler firmly believed that with hard work, he could carve out his own path. His talent in mathematics gradually became evident, and this caught the attention of the academic community at the time. Eventually, he was invited to join one of the most prestigious astronomical research institutions of the time, Tübingen University, where he began to pursue his dream of studying astronomy in greater depth. Mathematics teacher and astrology, finding a breakthrough from poverty. During Kepler's youth, his mathematical talents gradually gained recognition. In 1594, he became a mathematics teacher in Graz, Austria. Although the field of mathematics was not fully developed at the time, Kepler's brilliance quickly became apparent. During his time in Graz, he was introduced to astronomy and began actively studying the laws of celestial motion, laying the foundation for his later achievements in astronomy. However, unlike many other astronomers, Kepler's livelihood did not solely depend on his scientific research. He also had to rely on astrology to earn an income, a common practice for most astronomers of that era. In the late 16th and early 17th centuries, astrology was almost inseparable from astronomy. Many astronomers also practiced astrology, and even great scientists like Newton and Galileo had dabbled in it. For Kepler, although astrology was not his true passion like astronomy, it became a way for him to make a living. Kepler wrote astronomical almanacs that not only predicted celestial motions, but also included forecasts of celestial events, weather disasters, and other major occurrences. These almanacs were very popular at the time and attracted many readers who viewed Kepler's predictions as a guide to the future. Although Kepler himself did not fully believe in the accuracy of astrology, he used it as a means to support his more in-depth astronomical research. In fact, during this period, Kepler's engagement with astrology was both a pursuit of scientific research and a compromise made for the sake of making a living. His interest in astrology did not stem from belief, but rather from its ability to provide enough financial support, allowing him to continue his exploration of the mysteries of astronomy. For Kepler, astrology was not the ultimate goal of his life, but rather a means of survival, enabling him to maintain a basic livelihood and continue advancing the field of astronomy. Collaboration with Tycho Brahe, The Power of Data. In 1597, Kepler published his first astronomical work, Mysterium Cosmographicum, in which he proposed a completely new model of the universe. He sought to challenge the prevailing geocentric theory and explore a more mathematically and physically consistent view of the cosmos. Although the book did not cause a huge stir at the time, it successfully caught the attention of one of the most influential astronomers of the period, Tycho Brahe. Tycho was one of the most renowned astronomical observers of his time, conducting extensive and precise astronomical observations at his observatory in Uraniborg, Denmark, and accumulating a vast amount of data. Tycho's observational results earned him a high standing in the astronomical community, yet despite his unparalleled observational skills, his mathematical foundation was relatively weak. This made it difficult for him to extract further conclusions from his data. This was precisely where Kepler could shine. As a mathematical genius, Kepler had an acute sensitivity to data and a far superior ability to perform mathematical analysis compared to most astronomers of his time. Not only could he analyze astronomical observation data, but he could also apply mathematical theories to reveal the deeper laws governing the universe. As a result, Tycho recognized Kepler's talent and invited him in 1600 to become his assistant, tasked with handling and analyzing the complex astronomical data. This collaboration was crucial for Kepler because it marked his first exposure to such precise astronomical data, providing him with strong support for later formulating his 3 laws of planetary motion. It also allowed him to gain a deeper understanding of the true laws governing planetary movement. However, the collaboration between Kepler and Tycho was not without its challenges. While they complemented each other in terms of mathematics and observations, they held fundamentally different views on the nature of the universe. Tycho remained steadfast in his Tychonic system, believing that the Earth was the center of the universe, with the other planets orbiting the Earth. This view was widely supported by the Church and the academic community of the time. In contrast, Kepler firmly supported Copernicus's heliocentric theory, asserting that the Sun was the center of the universe, with the planets orbiting the Sun. This fundamental disagreement led to numerous arguments and tensions between the two. Despite these differences, Kepler remained steadfast in his beliefs and, through further research, used mathematical methods to prove the correctness of the Copernican heliocentric model. Drawing from the data provided by Tycho, he discovered that the planets did not follow perfectly circular orbits, but instead moved along elliptical orbits. This finding overturned the long-held belief in circular orbits and became the first of Kepler's 3 laws of planetary motion. This breakthrough not only changed the way we understood the universe, but also laid the foundation for later physicists, such as Newton, in developing the theory of gravitation. Discovering Kepler's 3 laws, overturning the cosmic view. In 1601, Tycho Brahe unfortunately passed away due to alcohol poisoning. Before his death, he entrusted Kepler with the astronomical data he had accumulated over many years. These data, especially those concerning the observation of Mars, became the foundation for Kepler's later groundbreaking discoveries. Tycho's data was incredibly precise, providing Kepler with an invaluable resource to explore the mysteries of planetary motion. Kepler began independently calculating the orbit of Mars and as he carefully analyzed the data, he discovered that Mars's orbital path was not the perfect circle he had expected, but was instead an unmistakably elliptical shape. This discovery deeply shocked Kepler and led him to question traditional astronomical theories. For centuries, the astronomical community had universally accepted that planetary orbits must be perfect circles, a belief rooted in the ideas of ancient Greek philosophers like Aristotle and endorsed by the Church. However, Kepler's data revealed that planetary motion did not follow this rule, prompting him to deeply question this long-standing notion. After careful thought and mathematical derivations, Kepler proposed his famous first law of planetary motion. The orbit of a planet around the Sun is elliptical, with the Sun located at one of the foci of the ellipse. This groundbreaking view overturned the long-standing assumption of circular orbits and provided a fresh perspective for future astronomical theories. With a deeper understanding of Mars's motion, Kepler continued to present one of his key contributions, the second law of Kepler. A planet sweeps out equal areas in equal times under the influence of the Sun's gravity. This means that when a planet is closer to the Sun, it moves at a faster speed, and when it is farther from the Sun, its speed decreases. This discovery established the first connection between the speed of planetary motion and its distance from the Sun, providing valuable data for future astronomical research. Building on this, Kepler further proposed his third law of Kepler, which states that the square of a planet's orbital period is proportional to the cube of the semi-major axis of its orbit. In simple terms, this means there is a mathematical relationship between a planet's orbital period, t, and its semi-major axis, a, expressed by the formula. T superscript 2 is proportional to a superscript 3. This law revealed the precise mathematical connection between the orbital period of a planet and its distance from the Sun, giving people a clearer understanding of planetary motion. Although Kepler's three laws were not immediately widely accepted at the time, these laws paved the way for future developments in astronomy. They revealed the fundamental principles of planetary motion in the universe, providing mathematical evidence for the scientific community and laying an important foundation for future physicists. In particular, Newton, when formulating his law of universal gravitation, based his theory on Kepler's planetary motion laws, successfully combining these laws with the theory of gravity to explain the mechanisms of planetary motion. Kepler's struggling years, poverty and injustice. Although Kepler made groundbreaking contributions to science, his life was marked by continuous hardship. As an astronomer and mathematician, his income was unstable, and he frequently faced wage delays, putting him in a dire financial situation. Despite these difficulties, he did not give up his passion for and pursuit of astronomy. During these challenging times, Kepler remained focused on his research, continuing to refine the planetary motion laws he had proposed and writing influential astronomical works. However, in addition to scientific struggles, Kepler faced even greater personal challenges. In 1611, his mother was falsely accused of being a witch and was subsequently arrested and imprisoned. At the time, witch hunts were widespread across Europe, particularly in Germany, where many women were subjected to torture and even death due to superstition and baseless accusations. Kepler's mother was no exception and was accused of witchcraft. This was undoubtedly a major blow to Kepler, and he immediately devoted himself to defending her. Over the next 6 years, whether through defending her before local church authorities or actively seeking legal assistance, he left no stone unturned in his efforts to save her. Unfortunately, despite Kepler's tireless efforts, his mother ultimately died in prison. This was a heavy blow to Kepler, and the grief of losing his mother undoubtedly added to the mental stress he was experiencing during this period, making his life even more difficult. At this time, the burdens of both science and family nearly crushed him, but Kepler did not give up. On the contrary, he continued to pursue his astronomical research, exploring the mysteries of the universe, and even made new breakthroughs during this challenging period. In 1619, Kepler published Harmonics Mundi, The Harmony of the World, a work that had a significant impact on the development of astronomy. This book not only summarized his previous research, but also further introduced Kepler's third law, that the square of a planet's orbital period is proportional to the cube of the semi-major axis of its orbit. This law was undoubtedly a major breakthrough for the astronomical community at the time. It not only explained the patterns of planetary motion, but also provided the theoretical foundation for Isaac Newton's later law of universal gravitation. Kepler's death and legacy. Kepler passed away in the winter of 1630 at the age of 58, due to his frail health and years of poverty. His life was full of challenges and hardships, but his contributions to science have etched his name permanently in the annals of history. His funeral was simple and sorrowful, with few family members in attendance. Despite his lifelong struggles for basic sustenance and never experiencing the honors or wealth he deserved, his ideas and achievements had long transcended his era, paving the way for future scientific advancements. Kepler's 3 laws of planetary motion, as the foundation of astronomy, transformed humanity's understanding of the universe. His first law overthrew the centuries-old belief in circular orbits, revealing the true nature of planetary motion, elliptical orbits. His second law explained the variation in planetary speed, establishing a mathematical relationship between planetary motion and the Sun. The third law established the relationship between the orbital period of a planet and the size of its orbit, laying the groundwork for future developments in physics and astronomy. Centuries later, Isaac Newton cited Kepler's laws in his Mathematical Principles of Natural Philosophy and further derived the law of universal gravitation. This groundbreaking theory combined Kepler's research with the theory of gravity, fundamentally changing our understanding of the laws governing the motion of the universe. Newton's law of gravity not only explained the interactions between celestial bodies, but also confirmed the correctness of Kepler's 3 laws, extending Kepler's influence for centuries to come. Kepler's immortal journey. Looking back on Kepler's life, he challenged traditional views of the universe with fearless intelligence and unwavering determination, revealing the inner laws governing planetary motion. His 3 laws not only revolutionized the scientific landscape, but also profoundly impacted humanity's understanding of the cosmos. Despite a life filled with poverty, illness, and family hardships, and even facing unpaid wages and social indifference in his final days, he never abandoned the belief in his pursuit of truth. His quest for knowledge never ceased. Kepler is undoubtedly a giant in the history of astronomy, and his name will forever be closely associated with scientific progress and the exploration of the unknown. His contributions not only laid the foundation for modern astronomy, but also paved the way for the scientific revolution that followed. Today, we still stand on his shoulders, continuing to explore the mysteries of the universe. If you enjoyed today's content, don't forget to like, share, and subscribe to our channel. Thank you for your support, and we'll see you next time.